The mystery of the thin avocado skin and the hard stone behind it. A surprising discovery. Prologue, an eye-opening first slice. Have you ever peeled an avocado, sliced the skin too thin, and noticed something different? This is where our adventure begins. We'll take you through the mysteries, one by one. We'll uncover the secrets of avocado anatomy that we rarely pay attention to. So get ready. Let's get started. Chapter 1. The mystery of the green color behind the skin. When you slice thinly across the outer skin of an avocado and look inside, you'll see layers of dark green, light green, and pale green. As you go deeper, the number of chloroplasts decreases, either because less light penetrates or because the color changes. As a result, the innermost layer, directly adjacent to the flesh, has only residual chlorophyll, making it appear pale green. Chapter 2. The uninvited guest, the hard rock under the skin. We find a hard white area, and upon closer inspection, we discover that these are stone cells, or scientifically known as sclereids. Stone cells are built for strength. They are a protective barrier positioned directly between the outer skin and the soft flesh of the fruit. They are located just beneath the thin inner skin. Their function is to protect the soft flesh from physical pressure and also to act as a protective barrier to prevent the fruit from being easily crushed. So why are they white and then turn brown? They store phenolic compounds within their cell walls. Once this layer is cut and exposed to oxygen, natural enzymes in the cells oxidize the phenolic compounds, producing a brown pigment called melanin. Chapter 3. When the wound glistens, the secret behind the cut. A deep cut in the skin appears shiny, and curiously, the surrounding green area also appears shiny. This shine comes from two sources. First, the cells in the skin and the underlying stone cells apparently store oil. When the knife cuts through the tissue, the cells break, and the oil oozes out, forming a thin layer like natural varnish. This layer reflects the light of a microscope, creating the shiny effect. Second, the ligneous walls of the stone cells can naturally appear slightly shiny if the surface is cut evenly. Furthermore, the damaged cells also secrete a cell fluid that moistens the cut surface. Chapter 4. The black traces left behind. Black scratches under the avocado skin. They look like small cuts, jet black, and appear to be located exactly where the hard white layer used to be attached. Remember, stone cells and their neighboring tissues are rich in phenolic compounds. Once an injury occurs, the enzyme polyphenol oxidase goes to work oxidizing the phenolic compounds into melanin, a dark brown to black pigment. The black marks are actually the fruit's own natural ink. Chapter 5. Why do skin and stone stick together? Why, when peeled, does the inner skin of an avocado feel so tightly adhered to the stone cells beneath? It turns out there's an adhesive layer called the middle lamella, rich in pectin. This pectin is like cement that binds the stone cells together. The stone cells are often irregularly shaped, jagged, or like interlocking puzzle pieces. When these two tissues meet, they don't just stick together, they interlock mechanically and chemically. As a result, the adhesive force between the skin and the stone cells can be stronger than the cohesive force within the stone cell layer itself. This means that when we pull on the skin, sometimes parts of the stone cells prefer to break off and go with the skin, rather than unraveling their bonds. That's why under a microscope, we see small fragments of stone cells still attached to the inner surface of the peeled skin. Chapter 6. View of overlapping rocks in a microscope. When we examine the inside of an avocado skin under a microscope at sufficient magnification, we are treated to an unexpected sight. It looks like a collection of tiny stones overlapping, piled up, and interlocking. The inner skin is actually just one or two layers of thin, transparent cells. The overlapping stones we see are the stone cell network itself. Because they are located directly beneath the epidermis, when the skin is peeled away, this layer of stone cells is exposed and appears as if they are part of the skin itself. Furthermore, if a small fragment of the inner skin is peeled away, the stone cells are completely exposed. Under the microscope, each stone is actually an individual stone cell. Their walls are extremely thick, making the cells appear dense and sturdy. They are packed tightly together, with almost no gaps, creating the illusion of a stack of flat, overlapping stones. Its polygonal, interlocking shape is the key to its mechanical strength. So, what we see as overlapping rocks is actually a living shield, a work of cellular architecture hidden beneath a thin green skin. Epilogue: Lessons from an avocado. We have now completed our exploration of the mysteries of the avocado skin. What started as a simple curiosity while slicing open an avocado's skin has turned into a scientific journey that reveals the beauty and complexity of nature's design. We learned that the avocado skin is not a simple sheet, but rather a layered structure with beautiful gradations of green. Thank you for watching this video until the end. If you enjoy videos like this, don't forget to support this channel by liking, subscribing, turning on the notification bell, and sharing. See you in the next Microscope Adventure video, and stay curious.